Hello, hello. Welcome to the stream. Give me just a moment to get ready. And yeah, let's start a new series, completely new. So, hope everybody is doing fine. I hope the sound is fine as well. I'm always afraid that it doesn't work. But it seems to be good. Okay. I think I'm basically ready. I do need some something to drink, but I can grab it later as well. Okay, so if everybody is fine, I think I'm gonna start. So, here we go. Starting a new project. Hello everyone. Welcome to VS Code, set up to run Zig. And I've been... Yeah, so what is going on? Why is this a new project? Well, I've been eyeing Zig for a while. I've been following it, how it's being developed, and also I've tried multiple times to start like making an engine, but it turns out that one of the problems with Zig is that it's fairly new, so there's not a lot of resources, there's not a lot of libraries, there's not a lot of there's not just a lot of knowledge out there about Zig. And being a new language, it's still not 1.0. It's changing a lot. And that is why, that's also why there's not many projects out there. So, but why did I decide to make something with it? Well, I think it's kind of becoming more stable now, and it is something that I just really love the idea of Zig. And I'm kind of starting to get tired of C, C++, and everything else, including Unity. Although I'm still fastest at working in Unity because I know it for like 10 years now. But I've been recently working in a Unity project for a client, and it's driving me insane. Every time I want to, every time you want to rely on it, there's something broken. Even in the newest versions, even in not the newest versions, but I mean the LST versions, right? So, years and years of suffering. In Unity has also led me to make my own engine in C++. which I started making when the pandemic started. I had a little bit of time and I was like, okay, let's try to make a toy engine. And then I made Shakedown. So, Shakedown Rally. I mean, it's kind of called Shakedown, but Shakedown Rally is the correct name. So, yeah, and then, but learning all the quirks of C++ has driven me insane, basically. It is interesting. I think that, it's always good to learn something new, to learn a completely new engine and build something with it. And also because my previous knowledge of languages was pretty much like C sharp, Python, stuff like that. So not very low level languages like C++ and C. Well, you can say that C++ is a high level language, but it's both low and high. It has really powerful abstractions where you can get into super high level programming, and you can change the bits individually, memory locations. So yeah, it's very powerful, but it has its own problems, right? So yeah, let me go on to the next topic. Why Zig? So why Zig? Well, as I was saying, C and C++. Yeah, this should be done now. C and C++. I was working in C++ for a while. I mean, I call it C and C++. It's not the same language, but I mean, under the hood, it's C, and C++ is just C with classes, right? Well, not really. C++ really has a powerful. I think that what really differentiates it is its powerful standard library, which is getting bigger and bigger every year and more complicated, and it's so overwhelming nowadays. But I think that kind of like the most powerful feature of C++. The reason why it's high level as well is this concept of RAII, resource acquisition is initialization, if I remember it correctly. Which is like basically what it means is that in one line you can like create an object, you can allocate all the resources necessary for it, and it will also destroy everything for you. I mean, it's kind of weird to explain it, but it means that in one line you can create a nuclear power plant and run it and do everything in one line, which is the epitome of high levelness of something, right? Because it's doing magical stuff behind the scenes. Zig is not like that. It's a little bit like that, but there's a lot of explicit allocations and explicit initialization that you have to do. But we'll get into that. Well, since this is like an introduction stream, I'm going to show off a little bit why it is. But Zig is more. You can't compare it to C++. It's more like much better C. That's how I look at it. Because C is very So one of the problems of C++, of course, is that it is built upon C, which is very, very old, and it has been made in the time where memory was limited, CPU power was limited, everything was limited, and just a moment. So yeah, that is so why Zig? It's a much better tool than C. C has a lot of problems that has not been once. I mean, when it was designed 50 years ago, is it 50 years? I don't know. Maybe it's 40 years. C++ is like 30 years. So I don't actually know, but yeah, C++ came as like C with classes. It has added this RAII concept, sort of, which is it is kind of the most powerful concept. But of course, it adds a lot of other things like templates, 5 levels of metaprogramming, which is yeah, which is why there's comp time in Zig, and I'm going to show it off. Anyway, so yeah, and let me show you. Yeah, I say why Zig. I actually have a separate file why Zig, or let's say why make an why Zig, why choose Zig, and why also remake the engine, right? So yeah, I think that the first thing that I like about Zig, I mean, this is very common for many modern languages. It's just, it doesn't have header files. I mean, that's just, the time I spent working on header files, because in C++, you have to declare your variables, you have to declare your classes, which is in your header files, and then you have to implement them in a CPP file, right? Well, talking about this as header files and CPP files is not really, it's not very precise. Like we say CPP and we say H files, but actually what it means is that there are compilation units, right, where CPP files are actually compilation units. Which are compiled separately, and they need to be bound by header files. So if you're including headers, you are and the problem with headers, a huge problem with headers, is that they're all in one. Like basically, when you're including headers, well, okay, maybe I should show it on my engine. I'm going to show off the engine anyway, so it's there already. Yeah. Let me load it. So yes, just the fact that you don't have header files in Zig, right? It is actually compiled. Well, you can say that, of course, there are header files, but they're actually collected. All your functions and everything is collected. And I think it's, the problem with C and C++ is that everything is linear. So if you define something before, if you define something, if you have like void one thing and void next thing, then in one thing you cannot call a next thing because it doesn't exist yet, right? Because it's like a single pass. And a lot of modern languages, including Zig, are 2-pass or multiple passes. I don't know. But anyway, yeah, you can't just do this in one CPP file. You would have to, what you can do in this case is you need to forward declare. So you can just say, okay, there's a thing that is going to be a next thing, right? So I am forward declaring this thing, which is implemented later. But this is a horror. It's horror to forward declare everything. And sometimes, yeah, so the thing is that you always have to think about including files as well in C++, which is, another horror. And you're always supposed to like try, if you can, forward declare everything and not include in header files, but only use compilation units or CPP files to include things. Which is, I mean, it's really hard to explain, but it is a mess. It is a mess, and you literally have to work with this mess all the time, every day. If you want to add something, you need to go into the mess, and you have to like, oh, do I include after or before? In Zig, you just don't have to think about it. It's like one huge thing you don't have to think about, right? So here is my main file in my shakedown. This is not the engine. This is just a shakedown. How many lines is there? 4,200, right? And yeah, this is where I basically include everything from the engine, but my engine is actually residing in precompiled headers, PCH. And I'm not even going to get started on precompiled headers. They exist for the sole purpose of speeding up compilation. That's what you need to understand. But this is where I include most common things. And the ways that this precompiled header compilation can break is infinite. There's so many things. I don't know. Just trying to install something, trying to add a new library. The other day, I was trying to. Okay, this is one of the reasons I'm considering Zig really, really hard. Another day, I wanted to create a Jolt physics. Not create, I mean add Jolt physics library into my engine. Hello, VFig, nice to see you. I wanted to add Jolt into my engine to try it, to replace Bullet, because Bullet is good, but Bullet has some problems with the polygon edges that I couldn't fix, that I couldn't solve, even with some of the utilities that it has. So I wanted to move to a better engine, and Jolt is kind of trendy now, so I wanted to install it. But I spent a whole day trying to make it run, and I couldn't. I had some linking errors because precompiled headers are breaking, and everything is broken. And I have it. I even have it somewhere here. Where is it? Xjolt. There it is. Xjolt. There it is. But once you add Jolt, once you include it, Visual Studio says everything is good. You can include Jolt. You can initialize things. Yeah, there it is. Once I try to do something, register default allocator, it just completely breaks. And I don't know. I just have some linking errors that I couldn't fix for a whole day. As precompiled header is such a terrible idea. Yeah, and I mean the only reason they exist is to speed up compilation, and I really need them because I need to be able to build my game in in 5 seconds. If I don't have this 5 seconds, well, actually it's more like 10 seconds. But I can't work on a game if it doesn't compile in 10 seconds. But look, linking errors everywhere. I don't know. My head hurts after this, and I was like, I don't know what's going on. Why I can't include anything? And it works in an empty project. Here it doesn't work because something is being included in precompiled headers. And yeah, whatever. I don't want to. I'm probably never gonna add Jolt into my C++ engine. Okay. So anyway, that's one of the reasons. Yes, the mess with header files, because everything you include here, I have this main CVP. Everything I include, it needs to be so. It means that PCH is gonna be the precompiled headers are gonna be on top. Okay, and they need to be on top. If you put them somewhere below, everything gets broken, right? And then everything I add, like particle system, it's just going to be inserted. So what happens when you include a thing? It's not like some kind of a magical 3-pass thing where you have like, oh, now you can use, it's not like in C# where you have like using a namespace, and then you just magically include other files, right? Other functions and variables, right? Oh, that looks like MSVC runtime related linking errors. Like part of your game is compiled with MTD and part with M something else. Oh, are you saying you know what the errors are? But you see, this is the problem. I need to I need to understand this, right? I need to know what the hell is MTD and M something else. Where did you see this? I'm completely, I when I see this error, I'm like, okay, what I do is I take this and I copy it into like into like my somewhere where I can see everything. Okay, so where do errors start? Here it is. Mismatch detected, runtime library, MDT dynamic debug. Okay, yeah. So maybe I should recompile Jolt with another flag. Is that a thing? Well, thank you. I don't know. But this is not the only linking error I had. Okay, I had like 10 in the line, and then at the end I just quit. I'm not saying I know. I'm saying I have an idea. MSVC has compile options for which version of the MSVCRT runtime do you allow to use. Multi-threaded, single-threaded, debug, not debug. Oh, I see. Multi-threaded. It really has to match across your entire build. Yeah, I understand that it does need to match. So yeah, I know that Jolt uses like a lot of parallelism, like multi-threaded. So maybe it is built with multi-threaded flag or whatever, something like that. Maybe I'll find out some other day. But thanks for pointing it out. And I'm not actually saying that Zig is going to fix this. Maybe it's not. Maybe it's not going to. But yeah, anyway. Anyway, let's go back to the Zig stream. Okay, so yes, I was talking about these forward declarations. By the way, I do have some forward declarations somewhere. For example, in let me remember, in Asset Manager. I think it was Asset Manager that I do. Yeah. In Asset Manager, I actually don't include any of these things. Vertex, mesh, shader, texture. What I do is I actually just forward declare them. And this is what you get, right? You have a class, and so, yeah, it is a struct. If you accidentally write class, it's an error, which is amazing. Okay, but anyway, yes. And somehow I can make a vector of meshes, even though it has no idea what. I don't actually understand how this works. Yeah, I think that error means that Jolt lib was built with a different setting for that than your game is used. I keep wanting to try Zig, but I keep remembering that they bullet point as a feature that it has more UB than C. And does it? Can you find that for me? The bullet point has more UB. Okay. But anyway, where was I? Yeah, so I remember that when I made this, my compilation times skyrocketed, like just forward declaring things. But yeah, you just have to think about this all the time, right? Like, oh, I actually want to like forward declare. But then if you want to like pass something as a parameter, which is not forward declared, if I remember correctly, which you want, like, you can't forward declare if you're passing it as a parameter. Yeah, because I remember I have these texture parameters. Yeah, I'm passing a texture params as a parameter into this function. And so if I only want to forward declare them, I can't, because it needs to know the size of them or something like that. I can't remember. It needs to be defined. It needs to see the definition of it. And so I had to move these texture parameters into a separate file. So I have the separate file just for the texture parameters, so that I don't need to include them into everything else, and then I can forward declare everything. It's just such a mess. It's incredible, you know. And then you have a feeling like, oh yeah, forward declaring is cool. I can do that, and then you get into problems. Oh, and one more thing, one more amazing thing. You can't forward declare nested classes and structs. So if I have a struct inside like this, right? I have this struct, although this is just a struct that I use once, which is just holding mutices. Is mutexes or mutices? I don't know. But yeah, if you want to forward declare this one, you can't, right? You can't declare this struct, although this is an unnamed struct. But anyway, yes, you have to put it outside, which is great. Okay, reading the chat. Zig uses undefined behavior as a razor sharp tool for both bug prevention and performance enhancement. Like, for example, Zig makes unsigned integer overflow UB. On the plus side, I think the Zig compiler warns for UB by default or something. Yes. Yeah, there are things where, like in debug, it will warn you. And there's also, when it comes to overflow and underflow, I remember that there are specific functions that you can use for detecting. Like it will actually detect overflow and underflow, but I can't remember if it is automatic or you have to use a special built-in function for that. If you want to like, yeah, I don't know. I didn't look into overflow and underflow. But yeah, I think that this is why I also like, because in C it's just like, oh yeah, here is a thing, and just be careful. Be careful with it, right? And it has like 10 sharp edges, right? But Zig is like, you know, it comes into a little, you know, it's like a very sharp knife that comes with a little, like it's really has a well-designed handle, you know, so it feels good to cut, and it's also like comes with a wrap, so it will not stab you if you don't unwrap. I don't know, that's how it feels a bit to me. But anyway, yeah, so my engine is a total mess, and whenever I want to add something, I need to panic. I need to look at the code and okay, not as bad, as you know, huge. I still can manage my engine, right? It's not as bad as huge code bases that corporations use. But yeah, there's a lot of things where you have to, yeah, and it just like because they're constantly adding some new, yeah, like this one. I made a macro, which is crazy, but I made a macro so that I don't have to write this. No discard, const expr inline auto. Not a great thing, but it's like, oh, you want because they always add new features that you absolutely want to use because it will save later. But then, you know, you have like no discard. You should put no discard everything. Also, they have stuff like no throw and, of course, consting everything, right? You don't want to pass everything as const. Well, in Zig, everything is const by default. All parameters are const always. So you don't have to put things. You know, it's much more concise language because of that. And I do have a macro for as t because static cast is just too long for me. Okay, so anyway, yeah, and it is a mess. Anyway, so let me go to the next thing. I will show off later some other features. But yeah, let's see. Did you write something else? No, this is the same thing. So yeah, no header files. One cool thing about Zig is it has integrated build system. So where C and C++, they're just like, yeah, you just build on your own. Use CMake, Premake, any of other 10 tools. Zig actually has a built-in build system. So it's kind of like a separate build program, separate Zig program that creates that compiles your zig, which is pretty cool, pretty nice. Yeah, let me actually start a project. Let me actually make a project. So the way that zig works is that, okay, yeah, I do have a little Python script to make a zig project. As you can see, I have many of them, but they're just testing basically. But I'm not gonna use my Python tool. Okay, I'm gonna make a new zig engine, and let's say zig, I don't know, stream test, something like that. It's a terrible name. Maybe not use a test in the name. Stream project, stream demo. Okay, let's call it the stream demo. And then what you can do is you can, well, if you just say zig init, and you have to use -exe, because there's also a lib if you're making a library, right? But this one will actually create a project for you for an application file. So if you create it, it will say created build zig, main zig, and then you can do a build as well. So what it has done is that it created these basically two files, build zig and main zig. Main zig is just like your C main, it's an entry point, but your build is, how zig builds your app. So now if I just go zig build, if I go zig build run, okay, it will build. Okay, let's do just build. So semantic analysis, blah blah blah. It's kind of slow in the beginning, but it gets faster later. LLVM, it does still use an LLVM, but they are actually moving to. They're planning to make the kind of like the debug compiler is going to be built in, as I understand. Hello, probably hell. Which means that it's completely like, yeah. Oh yeah, one of the things that I didn't mention is fast compilation times. Yes. In the future. So yeah, Zig is actually working on a how do you say it? It's not a progressive. I forgot. There's like in place build this compilation system. I'm terrible with names, but which will basically make you incremental, right? That's the thing. Yeah, the incremental compiler, which basically if you change something in your code, it will take like less than a millisecond to, or okay, maybe it's too much, but a few milliseconds, to compile. So it's I'm talking about the debug build, right? Not like super optimized build, of course. But for a debug build, it's if they promise that it's gonna be there are some demos. There is one video where Andrew Kelly, the creator of Zig, is like demonstrating the incremental compiler. But it's still not there. It's not there yet, but hopefully sometime in the future. Yeah, so it is still fairly fast, but I think if you just use C, for example, I think it will still be faster. I think that C is still faster if you use like I don't know, GCC. Because I remember compiling Raylib games was actually pretty fast. Anyway, yes. So yeah, this is also one huge thing because iteration time, right? Fast compiling means you can iterate fast. You can just change one value and test it, and you don't have to wait, a minute for it to compile, which is great. Which is great for making games. Anyway, so what was I trying to? I forgot. Oh yeah, right. I was making I was creating a thing. Okay, so I made a build, and what build did, right? If I say zig run, there it is. Oh, at least one positional argument. So maybe zig build run. No. Wait a minute. Bold. Oh, I got with bold. Build run. Okay, there it is. And it says all your code base are belong to us. Well, this is like a zig intro message instead of hello world. And it says run zig build test to run the tests. So let's go with that. Zig build test. I wrote build again. What the hell? Okay, nothing happened, which means that all tests passed fine, right? If nothing outputs, that's... I wish there was a little bit of verbose. Maybe there is a way to set it up, but, at least it says like 10 out of 10 tests passed. But yeah, we didn't even look into what's going on. So yeah, what it did when we built, it has created a zig out folder, which is where my binary is, and this is the demo. If I run it, nothing happens because of course it exits immediately after showing the string. But yeah, it will run if I run it in command line. But for now, let's open it into with code. So with code, let's look at this. Let's look at what it has generated. Yeah, I trust the code. Okay, well, and as I say, there's a main zig, which is your entry point, and there is a build zig. Okay, so as you can see, what is going on here? There's a lot of comments, which are a bit annoying, but they do explain really well what's going on, right? There's a build function, which does, well, this is basically your setup for the build. And as it says, it actually declaratively constructs a build graph. It's not actually in sequence. It is a graph, right? So you basically can define what are your target, which is like your platform. Standard target, it will be Windows by default. What are your optimization options, right? Is it going to be release build? And if you use a standard, that means it will be it will use whatever you define it in your when you're building it. Like you can use a compile option. And then, yeah, you define some names. Okay, you create an install artifact. Install artifact is basically like what are we making? Is it a library or an application? In this case, it's an exe. Yeah, creating artifact. You have arguments that you can pass into your main. Blah blah blah, and at the end you have. Yeah, you can run the app with the run command. And at the end, you have tests, right? Which you run with a test command, which we did. So what does that mean? What are the tests? Well, actually, should I? Yeah, well, I will show that later, actually. Yeah, it shows you that it integrates a build system into the project, right, immediately. So you don't have to use CMake, you don't have to use whatever, premake. I'm actually using premake for my C++ project. And if I open the, okay, give me some file. New solution, wait, why doesn't it say open in Explorer or something? Shouldn't there be... Okay, there it is. Yeah, so in my case, I'm using premake, and which is here, right, in this Lua file. And yeah, I can... Because, yeah, it's cool that premake uses Lua, but everything is here, right? I'm defining the links, my library dependencies, And yeah, but not everybody knows pre-make. Not everybody likes it. I even have some fatal warnings that I define so that it crashes here. Uh, but yeah, I do have, and then for each project I can define individuals. So I don't use CMake, but yeah, I heard all the worst things about it. I mean, it kind of like it can do everything, but everybody hates it, right? It's like one of those things that it's a necessary evil. And I literally just use CMake if I need to use if I need to build some other libraries, but I just use the GUI that I have. And I mean, it's kind of ridiculous that they made the GUI, but it's much more easier for me because it just gives you these bools that you can check, and yeah, and then you're like, okay, well, these are the things that I want. Build this. Yeah, build systems in C++ are a horrific nightmare, even though they exist for a lot of good reasons. Yes, exactly. Yeah, I mean, it makes sense. It makes sense why they exist, but it's one of those things that when they were designing languages, right, they didn't predict that it's building projects is going to be such a mess. And so, 40, 50 years later, we now know better. So Zig says, we're going to we're just going to integrate build systems into the language. It's kind of like going to be a feature. I mean, it's not a language feature, but it's feature of the Zig. Anyway, yeah, let me go next, and then I will show you the rest. Integrated build system, yes. Maybe this should have been a to-do file, so that I can say, so that I can, like, if this is a to-do, that I can do this. No header files, great. Fast compilation times, great. Integrated build system, great. Easy testing, yeah. So Zig has, so I have never made a C++ test, frankly, because I have no idea how. How do you even do testing? I mean, if I need some kind of testing, I'm just going to make a new project for my game, and I'm going to make a new project for the game, and then I'm going to just run something in like a separate project of my functions. I don't know, and that's how I test. But yeah, the thing is that Zig has integrated testing, which is done with you simply define a test. There it is. You create a test and you say simple test, and then this one tests an array list, which is basically a vector of 532s, right? It creates it, and then it appends a number, and then it expects the number, right? And it says, okay, try expect. If it expects correctly, it will. If this is untrue, it will error. Basically, that's what it means, right? So if it is true, do nothing, right? And that's why when we run Zig build tests, then it does nothing, right? Nothing, because there's no problems. But if we did have a error, why did I exit? Why did I leave this terminal? But you know what? I can actually run the terminal in here as well. So I'm gonna do a Zig build test, right, from here, and it does nothing because we haven't changed. But if I change this to like expecting 41, right, I'm just gonna run all the tests, and bam, there it is. One failed, and it gives you the explanation. What happened? While executing tests, one failed with exit code 1, and it says, what does it say? Okay, well, it does point to the test, right? Does it? Does it give you a line at least? Where's the line? Following test. Oh, well, of course. I'm stupid. I didn't look up. Okay, there it is. Test expected equal. It did not work, and then you can go to it, And oh, whoops, this is not the correct one. This is the one. Yeah, it comes from here, and like, okay, what is going on? Okay, yeah, well, it's this one. But yeah, anyway, and what is cool is you can add these tests into the same files. So when you're making a library, you can just add test file. You can just add tests. Simply create something, blah blah test, and do the try, testing expect something, true. Expect true. If I just do this, it will probably just work. Let me try. Yeah, it does work. Anyway, yes. So integrated testing, very nice. It actually, the thing is that, so this is the thing about testing, right? People say they hate testing. I also hate testing because primarily because requirements change all the time, right? And so you're changing your code all the time, and you need to like, oh shit, now I need to redo the test. But when it's so simple to make tests, just like this, it is like, oh, I actually enjoy making tests now. Once you kind of remove the overhead of making tests, it actually becomes amazing. 8 seconds to build and run is basically no up test. Yeah, that fast lies. Yes, but also consider that I'm working on an old laptop and also I'm streaming. So yeah, it's maybe twice slower. So yes, it would be faster on a newer computer, but yes, the incremental compiler would be very nice. That is true. That is true. Still not fast enough. Okay, anyway. Easy testing. Yes, amazing. Powerful metaprogramming with comp time. Yes, so, as I was saying, C++. C++ kind of has four... I have a feeling like it has 4 layers of metaprogramming. Is it true? Because C had macros, right? And macros... What are macros? Macros are just text replacement, right? Because even this include, what it does is that, if you have like this include, and I'm including GUI utils, what happens? What happens is that it literally takes this and then Control C and you Control V this here. That's literally what include means, right? It will just replace this text. And that's exactly what everything else is. If you say define something, define thingy, is whatever, std vector int, now that thingy is this, right? Well, without this. So if I now say thingy vector, right? It has become this. But what it does is that it just literally replaces this. And once you start replacing everything, it becomes incredibly difficult to debug. But for this kind of thing, you would probably use a typedef or something, which is like another layer of metaprogramming, right? Why do we have typedefs? Typedef, and now I forget how do you do it. Well, you can't actually typedef a template. That's another thing, because C++ has introduced templates, and you can't typedef them, if I remember correctly. And I remember that you have to do something the other way around. Do you just say int, and then I can say i32, something like that, and then I can use i32 as a typedef of int, right? I can do like this, right? I think that's the way. But it's super annoying. So C++, the new versions of C++ has introduced using typedef followed by a declaration, just as if you were declaring a variable. Right, yeah, it does make sense now. Yes, well, yeah, that's why it's confusing. Because if you're declaring a variable, right, you would write int the name, right? And yeah, it's the same thing with here. You're defining a variable of type in. My God, it's crazy. And then to make it more easy, C++ has introduced using, right? So yeah, now you can write using I32 equals int, and it's exactly the same thing. It's exactly the same thing. I wonder if this would compile. I don't know. Probably not, because you have two definitions. But yeah, this makes more sense because now this is, and what it adds is now you can actually using can actually how do you say, assign, you can assign templates. So you can do this. You can do this now if I'm not mistaken, right? Does it work? Yeah, I think so. You can do like vecchi. So now if I create a vecchi of vecchi number 2 is, oh yeah, well, no, that doesn't make any sense. But this is going to be a vector, right? A vector of int. Yeah, it does work. But the annoying thing is that if you have a void foo, right? And why I'm like, okay, no, wait. Let's say that I have a void of incredibly long name of function, right? And I say, okay, well, what about this? So why not? When I started doing C++, I felt like it makes sense that I want to like alias this, and I'm gonna call it foo, and I'm gonna use the incredibly long name function. But turns out you can't alias functions. It's not a type name, so you need to use a type name. But then C++ introduces this new thing, which is const_expr. So now you have this const_expr, which you can use incredibly long function name of function. Wait, is that it? No, I can't remember. I can't remember now. Wait, I have somewhere where I could actually do this. But can I do this? No, I can't. I forgot. Oh, probably because I need a type, which is auto. Is it? Does this work? Come on, compiler, tell me. I should have started a new project for this. Yeah. I forgot now. Maybe it is this, right? Can I do this? No, I can't. Wait, I need to find... where was this? I have this parse thing, but what is parse? CL parser? No, it's not this. Config utils. Yes. Here I have a template which can parse any number. And then there it is. I wanted to actually use a like alias for bool, int, and float. This is terrible. Don't use me as an example. This is terrible. I don't know why I did it. I just did it so that I can like reduce typing, right? But this is awful. This is awful. I just wanted to have a function. But yeah, turns out that you can actually alias functions, as you can see. This is a function. And you can even define a special template specialization. And you need to use const_expr auto. So suddenly you can use const_expr auto to alias things. Well, and this is where it gets, it's kind of like, now you suddenly have, oh, there, it actually works. It actually works. Just the IntelliSense was incredibly slow, which is another problem. IntelliSense is incredibly slow because of all these variants. So C++ has all these things, how you can do it, and we haven't even mentioned templates, right? Because it doesn't only have macros, type defs, usings. It also has templates, which can be, you can template classes, you can template functions, like here. Where was this? No, it was the other. It was this one. No, it wasn't this one. It was this one, right? You have templates, you define a type, and then you can use this type. And the thing is, the idea is that you can pass any type. So it can be an int, it can be a bool. In this case, I am also parsing a string. I'm parsing a, yeah, this is a const string. I have just aliased it to reduce typing, but it's not a great idea. Anyway, yeah, so I am like trying to, I can't even remember what I'm doing here. It has segments. Oh yeah, I'm magically reading a config from a from a parameter, and I'm converting it into, no, this is just converting into a string, I think. Is it? Wait, I'm not checking if it is a, right, I'm just checking if it has a segment entry, and then I'm parsing it. But yeah, try parse is also a, yeah, try parse is also a template. This is where magic gets magicceptionized. This is a template exception, because I'm trying to try parse. And then here's the thing. I'm using a new thing in C++ 23, which is concepts, or was it 20? I can't remember. And then I can define that it can be a int, float, or a bool. So that I'm parsing it from characters and turning it into a number. And this is an if const expr. If it is a bool, I do this, which is basically a converted. Any non-zero number is a true, and then else I am converting. Yeah, I'm converting a float from chars. I'm converting float to, or int to, the number. Coming from C++, yeah, everything Zig does is super attractive. Coming from a pretty conservative plain C only point of view, as I am, it looks neat, but not yet compelling enough to jump ship to. I agree. I think, yeah, I'm really actually looking forward to what is, how it turns out, how other people use it, and and yeah, and I mean, if there is the incremental compiler and everything, I think that's going to change the world. But yeah, I'm looking forward to that. Until then, we'll see. I'm mostly intrigued by the allocator API. Hello everyone. Hi Ray March. Anyway, I'm talking about this crazy ways of how many ways you can define, like you can alias things, and you have this kind of metaprogramming, let's say. And Zig basically just has comp time. And comp time does what templates do without having to use templates, right? And yeah, I will actually demonstrate later. I'm just saying that comp time is amazing, because what comp time does. Oh yeah, I completely forgot to mention const expr, because const expr can run at compile time. And yeah, so what is actually amazing about Zig is that it has reflection at compile time. So it doesn't have reflection at runtime. I actually kind of went into a really weird direction with this define type def using thing, which is actually not even important. But yeah, you can alias things. You can alias anything in Zig with const. Let me just say that. But what I'm talking about here is comp time. And comp time is kind of what we're getting in C++ with const expr. Which is like you can run anything at compile time. You know what? Let me just make a new C++ project. And by the way, I do have a little. I do have a little bit of a C++ project template, which is, by the way, on my Git. I made a little Python file to make new C++ projects, because setting up C++ projects is crazy. So I'm gonna do a Zig is great demo. Okay, and then I create everything, and it says, okay, make a Git repo. I don't need a Git repo for this. Open Visual Studio. Yes, I am going to open Visual Studio. So it even opens Visual Studio for me. It does not focus on the CPP file, though I didn't know how to make that. But I do have to do this. But it does compile right away. So I just have an empty main, and that's it. Build started. Look, it takes some time to build as well. But yeah, actually shorter than Zig, I have to say. For now. Let's see how the incremental compiler goes. So yeah, what was I saying? Yeah, you have these const expr things, right? So you can say const expr int. You can say, I don't know, add. And so what this means is that if I add these two numbers, I'm going to return a plus b. What this means is that this can also run at compile time. So let's say that we have a type of what is a compile time thing? For example, we can have a const expr int a, which is 10, and then we can have something else weird like const expr. Well, let's see. I think this is size t actually. A size t. Let's do a size of something. Size of no. Let's see this. If I say const expr int result, and that's going to be add a and size of. I don't know. Is there a std string, or do I have to include it? Let's see. So let's see what it does. Okay, it does work. Good, it does compile. But here's the thing. The thing is, when I hover over a result, it gives me a 50, right? And this is not, I'm not running this code. I did run it once, but I'm not running it right now. And if I, and the reason why I get this result, and it says that equals 50, is because it has been compiled. It has been already computed at compile time. So while I was running it, I can change this to 20, right? I can change it to 20, and result has changed to 60, because it has, while I was waiting for this result, while I was hovering, it has actually compiled behind the scenes, because IntelliSense goes through this and does it. So std strings is 40 bytes. Yes, it is. Yeah. If you hover over size of, by the way, it will actually tell you. It will tell you it's 40. And the interesting thing here, as you can see, by the way, string, std string is also, there is another interesting thing. First off, this is, it says that it's an int. It's not the size t, right? Which it should be, because it's a size of. But it is an int, because in this add function, it has already converted into an int. So it is pretty, it's pretty smart. But they had to add this in C++, and in Zig, you have this by default, and everything is comp time. Yeah, and another thing is that not everything is const experable yet. There's a lot of things like I think that you can't even allocate in const expr. I'm not sure if they have added it recently, but you can't allocate on the heap Everything needs to be on the something like that. I can't remember. Everything needs to be on the stack, if I remember correctly. And there are some, like in Zig, there's not such thing. You can comp time anything. Can you call the Wolfram Alpha API in context per function to get result of some complex computation? Probably not. I don't know. But I remember that this is one of the limitations, that like you can't allocate on the heap, but I'm not sure. Yeah, everything needs to be known at compile time, because this const expert compiler, I guess, that runs in the background cannot use the heap, or I don't know. I'm not a compiler creator, so I don't know. But it is pretty amazing that you can do this. But yeah, anyway, I wanted to say another interesting thing about, as vfig has pointed out, STD string is 40 bytes. Okay, let me show you some trick. Size of STD string. Let's put it here. Okay, and if you hover over, it says 40U, right? It is actually a unsigned long, which is amazing. Yes, I love C naming of variables. Unsigned long. Yeah. So, but it does say it's a U64. So you know, we this is a much better representation. And yeah, it is 40. But I'm gonna show you something incredible. Okay, I'm gonna go into my configuration panel, and I'm gonna switch it to release. I'm gonna switch the configuration from debug to release. And what's our size of now? Hey, look at this. It's actually 32. Suddenly, it has become 32 bytes. So actually, there's a difference between memory in a debug and in release mode. And here's the thing. The standard doesn't define how big the string should be, right? So any compiler implementer can make the string whatever size. But what exactly is in this 32, I'm not sure. Well, you need to explore that. So there's basically like there's basically like two size t's, right? If they're they're 8 bytes, so there's 4 of them, and I don't know exactly what. Why don't you use Emacs? I didn't grow up using it. I don't know. I wish I would. Or Vim perhaps. Anyway, yeah, what was I saying? Yes, I wanted to say that it depends on the compilation. And you know what? I'm gonna do something else. Well, this is a Zig. This is a Zig stream, but I'm talking all the time about C++. So yeah, I showed you that this is MSVC, by the way. This is the Visual Studio compiler, right? And in release, it's 32-bit. In debug, it is 40. So look at this. I want to show you something else. What if I change the compiler to Clang? I'm gonna change the compiler to Clang. I'm gonna whoops. Hey, what happened? Undo something. What did I do? Damn, I said undo something. Undo rename? I'm not sure exactly. I did some kind of a rename. Oh my god. What have I done? I've accidentally clicked something and I have no idea what. Okay. Great. Anyway, yeah, let me run premake again. Premake 5 VS 2019, right? It is a 2019, I keep forgetting. It's a 2015, right? Sorry, 19. Where's about? About 22. Oh shit! I totally forgot. It's actually 22. Okay, so I rerun it. I'm gonna. Oh wait, is it Clang already? No, it's not. Wait a minute. Oh, I actually did a C++ project template. Whoops. I did the wrong file. Okay, it's actually this one that I wanted to change. Great. Yes, amazing. Okay, let me do it again. Okay, so remember 32 bits and 40 bits. Okay, so this is now compiling with Clang. It says LLVM Clang here, right? So it does. Okay, so let's try again. Size of std string. What does it say? Size of std string 32, and it says ULL, right? It doesn't say U64 or whatever. Okay, let's go into debug. Let's go into debug. It's 32, just like the same. Oh, it is actually 40. Oh, I thought it was different between compilers. Maybe they changed something. I don't know. Maybe GCC has different sizes. Okay, whatever. I wanted to show you that it's different sizes of strings, but actually they are the same. Why don't you use Linux? Yeah, because I'm making games. That's the problem. Okay, let's see. I think they make the type a little bigger to store some more characters in it in case the short string optimization kicks in. I don't think it has to do with short string optimization. I think it has to do with debugging. They have some additional debugging information. Because like, if like bounce checking or something, I don't know. Maybe it speeds up debugging or something. Hello, RTO Talmine. Talminer. Bill Gates. Hey girl, want to know why I call it Microsoft? Sublime Text is this 2018. Sublime Text starts much faster than VS Code, I have to say. Yeah. I only use it to like start single files, right? That's why I have Sublime. You did undo rename. Yeah. But I have no idea what I renamed. That's the problem. I'm gonna see it on the replay of the stream. Control Z. Why don't you use Linux? Does Control Z actually work? No, it doesn't. There's no there's no redo. So I don't know. I did something. Shouldn't it be 24 bytes? If it's for debugging, why is it then 32 byte in release? I don't know. That's a good question. You should ask the compiler makers that. Okay, so yeah, I wanted to prove that it's a different size of string, but actually it is the same. Anyway, but look, Clang actually gives me some better debugging, better squigglies, and it says unused variable result. But the reason why I'm not actually using Clang is because it doesn't support new features. So you can actually use like file system, for example. It will tell you, oh, it's not a std. Is it file system? I forgot. File. Something like that. You can say copy file, whatever. And it will tell you like, oh, it doesn't, no instance of overload. Okay, no. I remember that it was completely unaware of file system because it's a 2017 feature. Doesn't matter. Okay, let's go on with Zig. Okay, so yeah, this is, I'm just now changing Shakedown. Let's repair everything. Okay. So yeah, I was talking about all the issues of C++, talking about not talking about Zig. So yes, amazing. Comp time is great. And it does actually compile C and C++ if you add it into the build, which means that it integrates, like, you can actually use all the C libraries that exist. You can use C++ does compile, but I don't think you can that easily use C++ libraries. I haven't tried that yet. So, and Zig is kind of, as I said, it's kind of like C, but with a lot of problems fixed. For example, in C you can just have an uninitialized variable. Oh, I just exited the other project. Why did I do this? Shaking up, shakedown. Zig is great. I don't know. Every online source I can find explains the 32 bytes by short string optimization. Is it an extra? Okay, but why? Please Google, why does it use? Why is debug 40 bytes? Yeah, that's what I don't understand. Okay, so anyway, yeah, I wanted to say something that, like, if you have an int of, I don't know, if you have an int a, what is int a? Not initialized? You see, Clang tells me that the local variable is not initialized because, compilers are smart now enough to tell you this. But back in the day, you could write this, and if I go with, okay, let me just remove the file system. If I say, give me the, output me the A, what is going to happen, right? What's going to happen? Oh, look, it failed. Expression result unused. Redefinition of A. Redefinition of A. I used A. Let's do a D, just because I can. And yeah, you can actually build it. And what's D? Well, it's 0. Somehow it is 0, but it could actually be anything, because it is actually undefined. So yeah, what if well, actually maybe Clang. Is it possible that Clang actually defines it as 0? Although I did get some errors. Variable 0, a D is uninitialized when used here. Unused variable. Yeah, it does give me warnings. MSVC, I'm not actually sure if it does. Let me try. If I remove Clang, and I'm gonna rerun premake, let's see. Okay, let's rerun this. Aha, it does actually give me. Oh, runtime check. The variable D is being used without being. Oh my god! MSVC actually gives me a warning. How is this possible? I don't actually get this in Shakedown. I definitely had uninitialized variables in Shakedown. And interesting. Okay. What if I do a release build? That's definitely uninitialized, and it's. Yeah, there it is. It will still give me 0. It does give me a warning. Okay, what if I have more things? Is it gonna give me gibberish at some point? That's what I want to see. Oh, it's always 0. For some reason it does initialize it to 0. But a lot of times it will give you gibberish. You have no idea what the variables are going to be. Clang would also give you a runtime failure on this if you had built with UBSun. Oh, there is a UBSun. MSVC has warnings for initial variables and stuff, but I don't know, maybe not turned on by default. I apologize for sending everyone down the size of string. And it says, why do you think? Yeah, rabbit hole. The STD string size. But yeah, it is interesting. I think it's interesting to understand why they have extra bytes for in debug. But I'm pretty sure that the standard doesn't actually define the size of the string. So any compiler can have their own size. If I'm correct. This article goes in data. It also talks about the 40 byte one. Cool. Right, we're down deep in the... we really are deep in the STD string size rabbit hole. Great. I'm wondering though why I'm getting this gibberish. Why I'm not getting gibberish. What if I have some huge array? How do you define arrays? I forgot. Classic arrays. This one, but you need to have the size. Okay, let's go with R88. Come on, give me gibberish at some point. I just want to see the gibberish. No, it's 0 again. Most of it is about the balance between small string optimization and efficiency of implementation, it seems. Okay, so it is still small string optimization, but why does it decide to use a bigger one in debug and a smaller one in in release? I don't understand. This is what I don't understand. That's why I felt like the 41 is just including some debug information probably in the string itself. But yeah, I don't know. Anyway, I'm not getting anything that I want from the compiler. I was expecting that it would give me it would give me some crazy gibberish. Probably has an easier time displaying the individual states of the string in case the SSO and 24 byte of the actual string are distinct. Okay. Since it starts allocating as soon as string grows to size of 16, they just store both. Oh, I see. I kind of get it. And is it smaller in release because they're like packing for better for size? I don't know. I see. Okay, anyway. Maybe my program is too small. Maybe my program is too small. I need to do something like this. Is this going to be a... Okay, what about this? Is this going to Stack Overflow? Yeah, there it is. Function uses 40,000 bytes of stack. Consider moving some data to heap. Yeah, if you just create a giant array in your function, which is allocated in a stack, it will actually warn you about having too much data on the... on a stat. It is actually nice that it does predict. Oh, and now it just gives me 0. Okay, but yeah, let's maybe the stack is cleaned up. I'm not sure, but no, that doesn't make any sense. But if I did actually like create a new array, let's do like malloc of R2 is malloc, and let's do some size. And then, yeah, well, I do get a, I'm just gonna do this, hopefully. This is not int at all, but let's try to output this one. If you get a place on the heap, which is unallocated, let's see what happens now. Oh, it's 0 again. How is that possible? I wonder if it still warns you if the actual size is a result of some crazy template instantiation. It has to. I think it has to, because crazy. I think it has to because constexpr needs to run at compile time. If it is constexpr. But can you actually instantiate? Let's try this. Now I'm completely not doing zig at all. If I do like class my class, but it's gonna be a template. Let's do a template type name t, and we're gonna have t inside data. Let's call it like that. And then if I do a size of my class of int, right? It does have to give me the number. There it is, 4. And if I do a my class of std string, it will actually give me 32, as you can see, because it's in release. It is in release now. Yeah, it is. Is this because dereferencing null pointer? Dereferencing null pointer? Is it null pointer? It's not null pointer. I am allocating this. Anyway, yeah, as you can see, it does give me a size of a template if I use a different type. So if I have 2 of them, it will, yeah, give me 64 and 8. So yes, if you had some crazy, ridiculous template, it will take forever to calculate this. And then imagine using a constexpr on some things. So that's why compilation gets slow, you know, because IntelliSense also needs to, and that's why you're typing something and then it's like, what is going on here? It's like the IntelliSense is super slow because it's like instantiating all these templates over here. Yeah, but can your editor afford to compile the document as it is edited? I think so, because I mean that's why it has this giant. So if you go into the VS folder, right, it will give you this IPCH files, which are basically, yeah, auto PCH, and IPCH is basically IntelliSense PCH. And in case, yeah, you can see that this is 68 megabytes. So it stores a lot of data just to be able for IntelliSense to work. And this is exactly, yeah, let me show you. In my engine, these files are like, where's .vs? There it is. They are like 5 gigabytes, right? 4.5 gigabytes. So yeah, and my engine is not even that big. So I wonder how it is for big engines. Anyway, yeah. So I think that's, like, it does use it does afford it through like paging and stuff. Yeah, can you build a Fibonacci sequence in template Metaprogramming real quick and use that as the array length to see if it stops at some point? Can you actually, how would you do a Fibonacci in? I don't think that actually will work, but let's let's break it. Okay, so how does Fibonacci work? You pass it a number, right? And then I'm just gonna add another Fibonacci, right, of A. I'm adding itself. That's Fibonacci, right? And if I make that, can you const expert that? And then call a const expert. Let's break everything. Const expert broken is fib1. Da 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 da. Expression must have a constant value. Expression not folded to a constant due to excessive const expert function called complexity. Oh my god, look at that. It does understand recursive functions. So yeah, and it actually broke pretty quickly. So yeah, excessive const expert function. I guess that this would also happen with templates. So it doesn't. Yeah, it doesn't. I mean, it's if it ends at some point, it will probably work. But Fibonacci doesn't end. So what if I add another parameter, which is like end limit or something, and then I'm gonna okay, let's do something like if I do something like this and I say if, oh yeah, this won't work because, oh yeah, it will. Wait, if limit is less than 0, return A. Okay, let's do this. And if not, we're gonna plus equal. What is it? What is this? Too few arguments. Oh right, too few arguments. I'm going to pass a limit. What does it say? Identifier. Oh, this is something different. Okay, let's do something like this, and then I can pass a limit of 10. Right. Wait, I'm stupid. Oh, but can I actually change a const expert value? Limit is 10. Qualifiers dropped in binding reference of type int to initializer of type const int. I guess you can't do that. I can't run it until a point if I mutate the limit. Expression must have a constant value. Cannot be interpreted. Expression cannot be interpreted. Interesting. So yeah, I can't mutate a const expert, I guess. What if I do this? No, that doesn't make any sense. What if this is const? That doesn't also make any sense. Fib to 10 would be 55. Yeah, wait, you just made an infinite loop. Yeah, I try to limit it a bit and then see how much how much complexity it would have. But you know what? Yeah, well, yeah, let's just do it with a constant actually. Uh, yeah, let's just say I instead of this, I'm gonna do a if a is more than 50, return a. So then it will actually end at some point. There it is. Let's try this. Aha, I think maybe this is even too much iterations. Let's see. Um, if it is more than one, does it work? Complexity, no. Maybe it just doesn't allow recursive at all. Maybe this needs to be const expr if. No, if const expr. No, it doesn't work because a needs to be const expr. Cannot be used as a constant. Yeah, this is compile time known things. So it doesn't allow even a little bit of complexity, I guess. Oh, there. If it is more than 0, it does allow. And then it's going to be 1. So once it has 2 passes through a function, it already says, function call complexity. So it doesn't allow these kind of functions. Anyway, this is ridiculous. Well, this is about Zig, not C++, but it's still interesting. Okay. Yeah, so I say that it has problem fix because in Zig you cannot actually define a. You cannot just say I32 and then do nothing, right? It needs to be initialized. Expected while for inline. Yeah, you need to initialize it basically to something. Oh wait, I forgot to put var or const. But yeah, this will say variables must be initialized. So you must give it a number, or, well, yeah, also needs to be used. Or if you want to be explicitly say, I want to not initialize it, then you can say undefined, like here. Undefined. And what it means is that it's going to be undefined, of course. But yeah, anyway. Yeah, I'll actually show this later. So yeah, why Zig? I did this. A more than 1 means infinite loop. That's not 2 passes. How? Okay. Because it will return just A. It will not cause another loop. What do you mean it's an infinite loop? Okay, let's try something. Let's do a non. Can this actually run? Even if it's const expr. Okay, it does run. A equals 1. You increment A after calling into fib. But I don't increment. I only increment. I mean, this is a return. So it will return A without calling the function. I mean, this is exactly the same thing as this. Wait a minute. I'm not even returning. You see, this is where C++ doesn't even warn me. Wait, does this work? No, wait. This, yeah, well, it still gives me infinite complete. Did I have a return before? Wait, I just incremented A and I didn't even do anything. You see, this is an error that it didn't catch. How is this possible? Yeah, so here's the thing. Here is the problem. I think the problem is that because it needs to run at compile time, it needs to run every path. And so even if you have an if, no, wait, does I'm confused. This works, but this doesn't work. Okay, am I stupid or is this Okay, so what if you do what if I do this at runtime? Okay, let's not do this. Instead, I'm gonna just output a fib of 1. Unhandled exception. I'm like, what the hell? Unhandled exception in Zig. But this is just the name of the project. Zig is great. Stack overflow. So it did overflow, as you have said. It's still infinite. Okay, I'm stupid then. But how? Increments A plus equals. Okay, it calls the Fibonacci, and then in the next sequence, it will be like, okay, it's more than 1. So it will be 1. Shouldn't it end? Wait, I'm stupid. It never increments for A equals 1. It doesn't increment. I'm stupid. So it will return a 1, which means that it will still increment. And then, but it doesn't call the function again here. This is what I'm confused about. Plus equals cannot be computed before the right hand side. Okay. So what if but what happens if I just do it in a separate line? Will this work? No, it still doesn't work. So it's not about plus equals. It is about calling the function. Right, but it does actually do it before, right? I'm not like, yeah, it makes sense now. Well, separating it to a separate line makes sense because I'm still calling it again. So I'm calling it again. Yeah, this is crazy. But how can I actually limit it? What if how is there a way that I can call fib function just 10 times, for example, and not infinite times? So that I can check where is the limit of complexity of const expr. Because I can't. But the check also has to be changed. Yeah. A minus 1. Or you do fib a plus 1. Yeah. If I try to do that. Okay. It does work. But how many times has it called? If I do more than 10. It still works. Okay, let's not make it const expr for a moment. And let's call a called. Let's try this. Oh yeah, it does work, except that I haven't added a new line. Yeah, there it is. So this is not a Fibonacci anymore. This is just adding a number. Currently, you never muted. Okay, so this is a recursive function that does end. So let's try what happens now if I do this. It still complains about must have oh yeah, this is because I removed const expr. So it does work, as we can see with 1. And it is going to be 66 at the end. So if we put this to more than 11, it's 78. So there it is. So when does the complexity end? Will it allow me to go to 1,000? Ah, there it is. Complexity. So it's some arbitrary point. It decides it's too much. There it is. This is 5,151. Okay. 120 works. 200. This is like guess a number now. 300. 400. 700. Okay, at 700 it decides it's too much. But it needs to run it, which is funny. Okay, there. 500 times. Still works. It's a huge number. 501. 512 maybe. There we go. 511. So it runs 500 and when it's 512, it decides it's enough. But it still compiles. Yeah, so this compiles, right? Oh yeah, it's a good question. Does it compile? Expression did not evaluate to a constant. Interesting. Where is this? Oh, it is this. So maybe this is separate from the IntelliSense. Okay, it does work with 1. Hey, it does work with 10. Does it work with 254.5? It does work. What if 256? It does work. So there's a weird number. Again, where it doesn't. 512? Yeah, okay. 511. Yeah, so this is the actual compilation is lower. Interesting. That's funny. Okay, this is a stream about Zig. And we're trying to break C++ compilation. This is too interesting. So for some reason, what about 510? Oh, it does work. 511 doesn't work. Okay, so what's special about 511? This is funny. 511, IntelliSense works fine. IntelliSense compiler is doing just fine. 512, IntelliSense says, no, fuck you. Excessive context per function call. Complexity. But the compiler at 511 actually complains that it's not a constant because there's too many iterations. Interesting. This is really funny. I would expect that the compiler would, increase the number. Maybe there is a setting somewhere, some magic setting where you can set up how many context per iterations, recursions is allowed. Yeah, anyway. I hope you enjoyed going down this rabbit hole for like half an hour or more. I think more. Trying to push const expert to the limit. Anyway, back in Zig. Yeah, C++ is too fun. Okay, so let me show you a little bit of Zig because I haven't done it in little. I didn't do much. Oh yeah, one more thing. You know what? There's a hidden part of this. I said all the positive things about Zig, and then I went into context per rabbit hole. But actually, there's a hidden piece here underneath, which is like, why not Zig? Well, first, I have to rewrite everything. Well, the engine at least. I already have a game working in C++, so why use Zig? One problem of Zig is it doesn't have too many libraries. I do actually use a lot of libraries in my engine. Yeah, getting them. But I say maybe because you can actually wrap any C library. But not all the cool stuff is C. So I don't know. It doesn't have. I'm not sure what, for example, what physics engine I would use for my engine, but we will see that later. And yeah, another thing is that I've only been dabbled in it for a little, and I don't know the language that well. Oh yeah, another thing why Zig I think that one thing that it does, it is good, is that it's a simple language. Unlike, I think C++ has too much complexity, like especially the new modern languages. It's not the modern languages, but the new iterations. You know, because you have the new standards C++ 11, 17, 20, 23. And I told you about all the context per stuff. So, yeah, Zig is a lot more simple than that. It is much more like C. And I will show you in a while. Well, I don't know. I'm starting to get tired. I might go to sleep soon. But anyway, it's the idea is interesting. Okay, so yeah, I do want to show off Zig a bit. So, the initial main Zig that it does is a little bit complex because it has all these tests. And it does show you how to use a little bit of an STD. But let's go through it. And the interesting thing here to notice is that it has this print function, std debug print. And the debug, yeah, you can actually use an info as well, log info. You can actually use a log info instead, which is one I use most of the time instead of debug print. And log also has other methods like error info warn. It's actually very similar to how SPD log works, which I use for my engine, where you have these like different levels of logging. So instead of print, I usually use std log info. And it does the extension, the Zig extender, even has a as you can see, it does have a snippet for it so that you can very quickly type it. But yeah, as you can see, sorry, Ray March says, just to clear up what I meant initially, that sort of stuff was what I was curious about WRT. If VS will show you the size of the stack, if you increase that number from 8 to a larger one. Oh, right. Oh, so maybe it's like the stack. And you could probably... Oh, I'm sorry. I'm getting tired. You can probably increase the number as well. And you're sending me a link to Godbolt, which I'm not going to click because this is going to be... This is going to be another rabbit hole. Anyway, it does show you how to use the buffered writer, which I don't actually want. Okay, look, let's actually almost begin from zero. Let's do this. Okay, and let's do a little log info. Okay, and I'm gonna say hello. And then I'm gonna do this world like this. Okay, and this should compile, hopefully. Zig build, let's do run. Hello world, there it is. Oh look, and this was actually pretty fast. It was a second or a sub-second. So I don't know what's going on there. Maybe there was maybe the tests are just slow. I'm not sure. But yeah, there it is. Hello world. And let's look at this. Let's analyze this a little bit, right? What is going on here? What the hell is going on here? First, in the first line, we have this const std at import std, right? So the first thing is that you can alias anything with a const. A const just means it doesn't change. And if it's in the top of your file, it means that it is constant throughout the function of the program. If you do use a const in a function, it does mean that you can initialize it, but it won't change. So it's very similar to how const works in C++, right? You can I probably have const somewhere in this. Let's find some const. Auto, there it is. I have, oh, well, const auto, this is a lambda. So that's not very, there it is. For example, I have this const string reference. Why do I even have a const string reference? I could have just used a reference here. Yeah, there. I have a constant string, which is my splat ID or something. Substring 9. Interesting. Oh, yeah, I am actually using the first part of the this is 9. Anyway, not the great way to do this, but it works. Anyway, yes, const just means you can't change it. If I want to rewrite splat ID into something else, it won't let me because this is a constant. Const matches these operands. Well, it's a weird way to say it, but what it means is that yeah, you can't assign to a const. And the same thing goes here. If I say a equals 15, it will tell me cannot assign to constant. Much better error. So yeah, but when it is at the top, it means that you're aliasing. std is import std. And why is there an at? It's because it's a built-in function. All built-in functions start with an at, and I think it's a great idea because it's very clear then what is a built-in function and what is a library function, which is not, in C++, you just use normal names for everything, so you have no idea what's a built-in and what's a library function. In this case, this is a built-in function, and yeah, you even have a little documentation here that it will find a path and then add it to the build, which is, yeah. And here's the thing. Here's a really interesting thing about Zig. Every file in Zig is actually a struct automatically. So unlike C and C++, which just copies with include, right? It will actually copy the file, as I was talking about in the beginning of the stream. In Zig, this is actually a struct which you access through this alias, right? So this is a struct, and then you say, okay, .log, and log is somewhere in std. So std log. Okay, well, this is not very, yeah, because log is also referenced. But if I had another file and I had a thing where I called it, yeah, let me show you. Another, let's just call it another Zig. And I had something in it, for example, some const a10. Is this going to work? I have no idea. Let's see. So if I say const another equals import, and then I say another, then I can access a through. Is this going to work? Let's see. Another. And I'm going to add a new parameter. Like this. Is this going to compile? Let's see. No package named another within package root. Interesting, but it is there. Import another. Oh, right, because it's lacking Zig. There it is. Whoops. Another zig. This is the problem. A is not marked pub. Right, it does need to be a pub to be visible outside of the file. Let's see. Does it work now? There it is. It does work now. There you go. It instantly compiled. Hello world, another 10. Great. Perfect. And yeah, so that is how you can include other files. I already showed you this. But yeah, it could be a function as well. You know, it could be a pub fun, and you know, give me something, and then yeah. Anyway, let's not do that. But you can do that as well. Fair enough. Okay, you probably meant about going down the rabbit hole. So okay, so we have gone through what this means, right? But what does this mean? Well, this is a public function, but does it actually need to be public? Does main need to be public? I don't think so. Oh, interesting. Main is not marked pub, so it does need to be pub. Interesting. Really interesting. I didn't know that. Okay. I guess I missed it. I didn't notice it before. And then we have fun, which is, you know, function. And then the name main. Of course, it requires to have a main as an. And then we have void, which is the return type, but there's also the exclamation mark. So what is that? That means that it also returns an error. So it means that it's either a nothing or an error. In this case, we don't actually return any errors, so it is kind of weird. The point is that it can actually be just void if it doesn't return anything, if it doesn't return any errors. But if we did return any errors, yeah, it does work. If we did have any errors, we would have to return it as an exclamation mark. So what is one of the things that will, for example, allocating yeah, pushing to a array list will actually, that's a try. But yeah, let's see this later. But this means just that it will actually return an error. So you can imagine it as like a union of error and a void, which is weird in this case. But in case of a number, it will, you know, it will be an error or a number. And here we see that we're calling the log info, which is inside std, and then we have this thing, which is like hello s. Okay, this is very similar to how standard format works in C++. And then we have this thing. Why is there a dot, and why is there a open bracket and close bracket? Here's the thing. If we had an info that just says hello, we would still need this thing, right? There it is. There's two of them. And what happens if I remove it? Aha, there is an error. I expected 2 arguments. Here's the thing. Zig, this is how we provide parameters for our string. But Zig, first, it misses 2 things from C and C++. One, it doesn't have function overloads, so you cannot have 2 versions of the same name. You cannot have this, and you cannot have you cannot have one argument function and 2 argument functions, right, with the same name. It would need to have a different name. And second, you cannot have arbitrary number of parameters, right? You can't do like, oh, now I want to have this and then this. So what you need to do is you need to provide a tuple. So this is how you define a tuple in Zig. And in the tuple, you provide all the parameters, because tuple can be any size. And here's the thing. This tuple is actually compile time. So info is a compile time. That's what I'm trying to say. And what it means is that it will actually make a separate method for each of the types that you pass. So if we have a string here and we have a const a, right, a compile time int in this case. Well, I'll talk about types a bit later. But yeah, we have 2 parameters. It will actually create a function that will have these 2 types. And if we pass some different, in case of this, if it is an empty, what's the problem here? Expected 2 arguments, found 1. Oh, yeah, because I didn't save. Yeah, it will actually create a new function, which is, it will instantiate at compile time a function that has, no parameters. So these are actually essentially 2 different functions, but they're not overloads. They're just 2 different functions that are instantiated by the compiler. So I like this idea. I like this idea that you kind of need to pass a tuple. And the thing is that this is actually implemented through a... Let me see if I can actually look into it. Oh yeah, there it is. The thing is that you can pass it as any type. And any type means that you can you basically have, as I said, you have reflection, right, at compile time. And what it does is that, well, this one actually passes, yeah, and then it will have the anytype. And let's see, oh, there's even more. There's even more depth. I want to see how it goes through anytype, because it must for loop through them. At some point, anytype args. Okay, where are the args? Where are the args used? They're not used at all. Wait a minute. How is this possible? I'm confused. Keep sig pipe. There's only one mention of args, and it's not mentioned anywhere else. So what happens with it? Interesting. I guess I'll come back to it later. Maybe it is wait, this is actually a const. This is like a lambda, or it is creating this function at runtime, at compile time. Options. Yeah, this one actually... This is just a definition of a function. I'm looking into wrong things. Isn't it? Right. Because it just has an equals. And it's not actually open bracket anywhere. So it's not actually defining the function here. But you see, the point is that Zig code, the standard library, is actually readable. Like, I do understand what's going on here. I do understand that these are aliasing other files. And there is a log as well. And if I try to read the C++ standard library, I wouldn't understand anything. So that's the difference. And I don't know where the args are being compiled, though, where args are being interpreted. But it does have a, I know that it does have a compile time for loop that goes through all the parameters. Because I've done it before. Anyway. So yeah. I'm a bit lost though. Let's see. I want to... What's another thing that I wanted to show? Yeah, well, this is basically the basic thing, right? This is just the output of a file. Not a file. I mean the... Okay, I'm starting to get really tired, so I might go to sleep soon. But yeah. Any questions? Rescue me from the rabbit hole. We spent too much time in the C++ rabbit hole though. Show off Zig a bit. Did I actually show off? Probably not. So yeah, Zig has basically there's two ways that you can define variables. You can do a const, which is your constant, which cannot be changed, and a var. And the difference between a var and a constant is that this number is actually a comp-time int, which is interesting. So this is the same way as in C++ you would define a number. You would say like here you would say let's do this one. You would say define what? I can't write anymore. Define a, and you say, I don't know, you say 10. So you have actually, this number is not an int. It's just a number, which is going to get replaced into anything that you write, right? So this is what Zig calls comp-time int. It's not actually like a type. Like a type with a size. It's just a number. But the var that can be changed, oh, it is a comp-time int, but I don't think it's actually valid. I don't think that this is... Let's try to see if this is actually going to output anything. Oh yeah, this is not used, so it will create... this actually means... So in Zig as well, you must use a variable. And if not, the Zig format actually does this for you, which is strange. It means that, yeah, just use this variable for something, which is nothing. Well, this is just called a discard. So you discard a variable explicitly. And it is kind of weird, but what it does just mean, if you have this in production code, you should just remove this, because this is a completely unnecessary define. But as soon as you use it, like here, it will actually disappear automatically. So you discard it, but as soon as you use it, you don't need to discard it anymore. So let's see what happens here. Is it going to work? Variable comptime int must be const or comptime. There it is. So it doesn't allow you to actually have a comptime variables. What that means is that you have to explicitly assign it, explicitly make it a certain type, which is not comptime int. And we can do a i32, for example. And now, this is the way you define your type, unlike in like C style where it would be before. And I get confused with this a lot because I really I really think about type first. But that's just because I know C and C++, and most of the and C# as well, though, because C# is pretty much based on C and C++ syntax. But most modern languages do actually have a post, even TypeScript, if I remember correctly, and Python as well. And yeah, they do have a type after defining a variable, which I do prefer, but it's more like my roots in C, C++, and C# are forcing me to think about type first, and then what the variable name is. And yeah, now it should work. There it is. B is 0, which is exactly what it is. And as I said, you cannot have undefined variables. If I try to do this, variables must be initialized. So in Zig, everything must be initialized unless you explicitly say undefined. And yeah, let's try to run it. And what does it say? There it is. B is minus 1 billion something, right? So because it's undefined, whatever was on the stack, it will be assigned to it, right? But the point is that unlike in C and C++, where you can so easily accidentally not initialize a variable, in Zig you have to explicitly not initialize. And this is pretty cool. This is pretty cool because it can catch a lot of problems, which I even had in Shakedown. I even had some uninitialized variable problems, which were sometimes hard to debug. I would have to go over everything, like, why does this number have such a crazy value? And yeah, especially when it comes to physics or position or something, and it suddenly becomes weird and unpredictable. So in Zig, you have to explicitly undefine or uninitialize. I mean, create a number without assigning a number to it. And the interesting thing about this method of you must initialize everything is structs. So the way you actually write structs in Zig is you don't go struct my struct and then you define the struct. Here in Zig it's a little bit weird, but I do kind of like it. I do like in principle, but it's just weird to write because of the of my background in C, C++, C#. But you basically alias your struct. So you say const my struct is a struct. So it's almost like every struct in Zig is anonymous, and so you just like, oh, I want to name this struct with my struct, right? So yeah, it is a bit weird, but once you get used to it, it's not really much of a problem. And then you can define things like, okay, I'm gonna have some number i32. I might have some float, right? I might have an f, which is f32. And by the way, yes, in Zig, you write your numbers like this. And then what happens is that you say, okay, I want to have an instance of my struct. Let's call it Meister. Great. Great name. And I'm going to have a my struct. Right. And here is the thing. This is how you define a struct in Zig. You can create an equals and then do this, and then it will create a struct. But here is the thing. Let's do a std log here, just so that we use it a bit. And let's say Meister, and then Meister A, and I'm gonna output the f as well. So let's do this. Okay, I try to run it. Oh, there is a problem, and that is that missing struct field A, which means I need to initialize my struct field A. There it is. It is actually, what this means, missing struct field A, is, wait a minute, you haven't initialized these numbers. So each thing in a struct needs to be initialized. My struct declared here, this is just the same thing that it will, it's sending me to declaration of the struct. Oh, by the way, one more thing about Zig. The interesting thing about Zig is that you can define. Oh yeah, by the way, the auto Zig formatter, right? If you make a string where each parameter has a comma at the end, it will actually keep this structure. If you remove the comma and then save, it will actually put your struct like here, like this, in one line. And it was really confusing in the beginning, but when you realize this difference, it's actually kind of cool. It is weird, but yeah, it actually allows you to have things in line. And it was, even if you add some functions to it, because you can add functions, I think it will probably, oh no, it does actually put them in separate lines then. Yeah, but because you have these, like, if you have some super simple pod structs, as they're called in C++, plain old data structs, like here, you might actually want to put them in one line. If you had like a vector or something, and then you had, if you had a vector and then you had x, y, z, then, it makes more sense to put them in a line, perhaps. And then, you have a syntax like this. But if you don't want to put them in a line, you can just add a comma at the end, and there you go. It will be, oops, I have two y's. So now I have struct that is laid out in rows, which is funny. But that's the auto formatter that Zig has, that the extension comes with. And I do recommend using it, because one of the rules of Zig is to have as little difference between code bases as possible. So, which is another thing I like, because when you look into std, it's not written by some crazy person. It looks like everything is consistent, and it uses the same spacing and the same formatting as all other code. Going back to my struct example, okay, let's add a comma here. And yeah, what this means is that you need to initialize every parameter. So here I will have to type .a is 10, I don't know, .f is 0. I don't know, it could be 2. Yeah, in Zig there's no 2f or this. Is there? No, I don't think so. No, there isn't. Okay, yes. Oh, and of course, you need to do this if you want your row-based layouts. Yeah, so now I can build it, and it will output me these two numbers. And it does write floats like this, which is a little bit annoying. I think there is a way to format the strings. Is it like this? I can't remember now. There is some way to format strings. Or is it F? No, it is like this. I forgot. Invalid format for type F32. I am going to look at it later. But yeah, there is a way to format your floats without using this weird notation. But yeah, this would, initializing structs manually, if you have some nested structs, it would be crazy to do that, right? If I have some nested struct, which is like another struct, and I say A is I32, I have another A, or let's say nested num is I32, and let's say that member of this my struct is the nested struct. Let's call it str nested struct, which is of type nested struct, right? This should work. Oh, res. I did forget a semicolon. Is that the problem? Oh yeah, the problem is that I'm not initializing here. So if basically I have to initialize it as well. And this is going to be the nested struct. This, and now it should work, no? Like this. Nested missing struct field, nested num. Yeah, of course, I need to define a nested num as well. So it doesn't allow you to define anything, which is pretty cool. Okay, let's see if this works. It should work. Yeah, there it is. So yeah, it does have a nested struct. But initializing all of these things would be annoying. So, but here's the thing. You can actually define defaults. So if I had a nested struct that has a default of 0, let's say this, right? And A has a default of 10, let's say. But it doesn't have a default of F32. So what this means is that we can still build it, right? If I omit an A, it will have 10. It will still be 10. Oh no, there is an error. There is an error because unable to update file. Access denied. Okay, transitive failure. This sometimes happens. Okay. Probably because I was building it at the same time. And there we go. We have Meister is 10, even though we haven't defined it. But if I try to remove F, it will still complain as it should be. There it is. It's missing stripe F. So anything you don't default needs to be defined in where we create it. But I can override A if I want in the constructor of this. Well, here's the thing. Zig doesn't have constructors. Ta-da! Zig doesn't have constructors, but it has this. You have to assign all the values like this, right? And these are all just numbers, right? I mean, not just numbers, but basic data types. They're basic data types. They're not some kind of a crazy initialization thing, which happens in constructors, usually in C++. Okay, so, but here's the thing. If I had a float for each of these things, if I had initialized all the values, in the end, I don't have to define anything. I can just do my struct, and there we go. And let's see if this works. It doesn't work because the struct field str is not defaulted to anything. There it is. I do need to define str because we haven't actually defined a default. And I am here going to create a default like this. And it doesn't allow you, the Zig doesn't allow you to do this though, I think. Does it? Error. Tuple field has a name. Tuple field has a name? Okay. Oh, shit. No, wait. What is happening? I think it's just confused by this. Yeah, exactly. Yeah, you need to define it like this. But I think the name can be omitted. So you can see that I have defined a struct and it's already defaulted to other things and nested as well. So I think it's a good idea to always define defaults. But here's the thing: if I remove this, if I have only this, what happens then? Aha, there is a bug. Found void. Right. So empty parentheses are actually a type of void. And yeah, I think you need to add a dot for it to be inferred. But I'm not exactly sure. Let's see. Yes, there it is. It runs. So, to infer a type, you add a dot. And if it's not being automatically set to something, it will be an anonymous tuple. So that's where this comes in, right? As I already told you, this is how you define, because it doesn't have function overloads. You cannot pass multiple values. You have to pass it a tuple, and this is actually going to be an anonymous tuple, or you can say an anonymous struct that has two members. And in this case, this is not going to be an anonymous struct. This is going to be a struct of type of nested struct. So the dot just means infer a type. And if there's no type to infer, it is anonymous. And I kind of really like that. I like this idea, at least. Okay. So we went over some of the basic parameters, and I think I'm going to go to sleep now because I'm getting really tired. I am drinking coffee, but it is quite late here. It's 2 a.m. So I think I'm going to continue some other day. And I thought that I would go and show some... I don't know. I might even like draw a triangle or something, but no, I'm still at basic values and showing off the basics of Zig. Let's see. What was I planning? Show off Zig a bit. Go over Shakedown engine libraries. Oh yeah, many libraries of Shakedown, which yeah, there's too many of them. And I mean, this was just going to be kind of introduction into making the engine, but I'm not there yet at all. Go over how Shakedown engine works. Yeah, I'm gonna move that for the next for the next video on Zig. But I think I might actually do the next one. The next stream is going to be more about Zig, other Zig features, such as errors, optionals. I kind of want to go through that. Arbitrary int types, packing structs and stuff like that, which is that's the interesting stuff of Zig. Because yeah, I did mention that I am writing I32, but you know what? It can also be an I31, and it's totally a valid thing in Zig, which is really strange, but it is valid because it takes arbitrary bit numbers. And in this case, it doesn't really matter because this is all going to be aligned to the 32. But if it's a packed struct, then it would actually matter in memory. And there's a lot of these cool tricks. And of course, I didn't even use any comp time features. But yeah, for the next stream, I'm going to show you some. And I think I'm going to prepare much better for the next stream because I realized that I haven't shown much of the cool stuff. So yeah, I hope you enjoyed this first look at Zig and why I'm interested in it. And I hope you enjoyed going down the rabbit hole of why is std string in C++ this big, right? Why is it, where is it? Why is size of string 64? No, wait, this is my class. Why is it 32? That's what I wanted to say, which is interesting. Okay, anyway. I think Zig is cool, but we'll see. We'll see when I start making the engine, which I have no idea if it's even going to work. Okay, so I guess I'm gonna see you on some next stream, and it's probably not going to be tomorrow because I am going to continue working on Shakedown Rally in C++ still, but this is more of a weekend project, so maybe not tomorrow, but some other day. Yeah, hope you enjoyed the stream. This was a purely coding stream, not much to look at. But yeah, thanks for watching again. See you next time. And follow me on like Twitter and or my games Discord, which is in the description below. Yeah, that's where I'm going to announce when I'm going to do the next Zig stream. Yeah, hope you enjoyed it. See you next time. Good night, if you're in Europe. And have a nice day if you're on the other side of the globe.